4.2 though, division of fractions. So in the last section, of course, we talked about 4.1, multiplication of fractions. As it turns out, we don't actually divide fractions, and that may sound weird, but it's true. And I'll get more into that here in a second, but before we do, there's this one word, this vocabulary word that you need to be familiar with when dividing fractions. Now, the word reciprocal here and here, some people, instead of say, oh, well, it's the reciprocal, they'll say the flip. It's going to flip, okay? So it's a matter of flipping the fraction. You may notice that with this example that's given, whatever's in the numerator becomes the denominator, and whatever in the denominator becomes the numerator. And you can switch this back and forth as many times as you need to if you say it's a reciprocal and reciprocal and reciprocal, which is why this arrow is pointing both directions. All right, doesn't matter which one you start with. If you reciprocate a fraction, you're just flipping it, or more technically, reciprocating it, so that numerators become denominators, denominators become numerators. Oh, there we go. Yeah, it's at the bottom there. Reciprocal flips the fraction. So, and we're getting to a point here. There's a reason why we're looking at reciprocals, but for these first few fractions, the only thing we really want to do is, well, reciprocate them. All right, so I like to show this with a little arrow like this, just so I know that I'm not showing something that's equal to it, okay? So 2 over 3, I've got the 2 in the numerator. I'm going to switch it to the denominator, and the 3 in the denominator will now switch to the numerator. And that would be the reciprocal of 2/3. 3 over 2 is the reciprocal of 2/3. And then I have 7 over 5. Again, I'll show an arrow to show that I'm reciprocating this. Here's my fraction line. So the 7 in the numerator will now switch to the denominator, and the 5 in the denominator will switch to the numerator. There you go. That is 5/7 is the reciprocal of 7/5. And then 11. So some students look at 11 and they say, hey, this can't be reciprocated because it's not a fraction. But just like we learned in that last section, is that it can be written as a fraction, right? We would make this 11 over 1. It's the identity property for division. So we divide it by 1 here, which then allows us to reciprocate it. Now, instead of it being 11 over 1, the 1 in the denominator will be the 1 in the numerator, and then the 11 numerator will become the denominator. That's it. I'm pointing this out. We are going to be using this word reciprocal, I don't know, pretty often in this section at least, probably in the next section as well. But you need to get used to that. When I say we're reciprocating a fraction, it just means we're flipping it, okay? Or if you hear this in the future, they say we're going to reciprocate a fraction. Again, it just means that we're flipping it. All right, so this is where we find the importance of reciprocating fractions, okay? And this goes back to me saying we don't actually end up dividing fractions. We do not divide fractions. What we do is we reciprocate the divisor here. And you can see that it's C over D, it becomes D over C. But when we reciprocate this fraction, what happens is we change the operation to multiplication. Okay, so what we're going to do is we're going to take the division and always change it to multiplication when dealing with fractions. Again, if this was just multiplication of numbers, it wouldn't be a problem, or even division of numbers. But when we divide fractions, we don't actually end up using the operation of division. We use the operation of multiplication, and that's why we start this module with multiplication of fractions, okay? So again, but it's crucial to remember that it's the divisor that gets flipped, not the dividend. The dividend has to stay the same. It's the divisor that flips. So some simplification may be necessary. Once you get it into this multiplication, again, you got really 3 strategies to work with. Cross simplification. You can break down the numbers into their prime factors, or you can Oh, I forget the third method. It seems like we just multiplied straight across and then simplified in the end. But I feel like I missed one in there. In any case, it doesn't matter how you simplify it, just as long as you do at some point, because the answers for these problems need to be in their simplified form. Yeah, that's what it says down here. Do be careful, because some fractions, they'll throw one of these at you from time to time where just the straight fraction in the beginning could be simplified in the beginning. So if you see it, you're welcome to simplify it in the beginning, but it's not required that you do. So if for some reason you miss this, which is why it's a little bit smaller, if you miss the simplification in the beginning, that's okay. It's not a big problem. All right, now that may not make a lot of sense right now, but I hope it will by the time we finish, even this one example, because this one's going to work out real nice for us, okay? All right, so remember, this is showing division of two fractions. Now, I'm still going to keep the two fractions, but I'm going to change my operation to multiplication. And the second fraction, which is 14 over 5, I'm going to reciprocate it. So now where it was 14 over 5, it becomes 5 over 14. Okay, and again, that's my divisor in this division problem. All right, we have a dividend of 1/10, a divisor of 14/5. I'm only reciprocating the divisor here, which now makes it 5/14. Now the 1/10, the dividend, it's going to stay the same. The dividend will always stay the same. And then we're just looking to simplify. Again, you can simplify now, you can simplify later. It's not going to matter. I am going to cross simplify with the 5 and 10 right here. So I'd say, well, the 5, I crossed them out. Maybe I shouldn't. I should show the division here, right? 5 I know is divisible, dang it, by 5. There we go. And then 10 is divisible by 5 as well. All right, so let's see what we get out of that. So the 1 and the 14 didn't do anything to those. I don't see anything that we can do to those. But 10 divided by 5 is 2, and 5 divided by 5 is 1. And now I don't have any other cross simplification to perform on either of these fractions that are being multiplied. So just do the straight multiplication here. 1 times 1 is 1. That's good. And then 2 times 14. These arrows right here, of course, are showing multiplication, because with fraction multiplication, you're just multiplying the numerator straight across, and then you're multiplying the denominator straight across. 2 times 14 is 28. So this actually is our final answer. Yeah, and I don't see that it could be simplified. Of course, with 1, it shouldn't be able to be simplified any further from there. But again, just going back to just after the reciprocation right here in this step, whether you cross simplify like I did right here, or you broke these down into their prime factors, or you just multiplied them straight across, and what would that be? 5 over 140, and then simplified from there. You'll get the same answer. Well, let's go ahead and divide these. So once again, and it doesn't really matter how you do this in order, right? Like on that last problem, I said that we reciprocated this one first, and then we wrote in the dividend. So on this one, I'll write the dividend in first, just because, again, I'm showing that it doesn't matter. I am changing the operation from division to multiplication. That's crucial. But if I do change that operation from division to multiplication, then I need to reciprocate the 5 and 2 from our divisor fraction. So instead of it being 5 over 2, it's now reciprocated to 2 over 5. Now, I did cross simplification on that last one. I guess I'll just kind of rotate through the strategies. Again, it doesn't matter which strategy you choose or that you prefer. Just keep using the one that you prefer, whether I use it or not. And then make sure your answer ends up being the same, because if it's not, perhaps it could be simplified, or maybe a mistake was made with the multiplication. I may make mistakes too, of course, since we're just practicing right now too. So I'll use prime factorization on this one, and the only one of these 4 numbers here that I see can be further broken up is the 6. Right, so this is going to give us 5 over, I'll break up the 6, but the 2 and 5 in the divisor now, or I guess the other factor there, is going to stay. So, but I will break up the 6. 6 will break up into 2 and 3, or 3 and 2, it doesn't matter. But those are prime factors of 6. So now, with this method, then I look for any matches in the numerator and denominator. And yeah, we even have matches from the 5s that were already there. And yeah, 5, well, I didn't break up the 5 because it's already prime. So those will become phantom 1s. And then I see I got a purple 2 and a green 2 that match. So those are going to become phantom 1s. And that's all the factors that I can cross out as phantom 1s. Now, I notice in the denominator I've got this 3. That's all that remains. But this is if this method is used at this point, sometimes it throws students off because it's like, well, I crossed out all the numbers in the numerator, in both numerators, which is true. But remember, it's not that they're canceled out, that they've gone away. It's just that they became phantom 1s. So just show either one of those two. I'll choose the red phantom 1, which means that our final answer here is 1/3. So dividing on this one, no problem. We can do it. But when I do this one, I am not going to use division. I'm going to use multiplication, right? So I'm going to change the operation of multiplication. My dividend stays the same as 7/8, but the 6/7 here is going to flip or reciprocate into 7/6. All right. Now, the third strategy, which I said I would use, is just where we multiply these straight across, and then we'll worry about the simplification after we actually perform the operation of multiplication. So let's go ahead and multiply these, and then we'll see. And some of you already know how this is going to play out, but 7 times 7 is 49. That's my numerator, and then my two denominators multiplied. 8 times 6 is 48. Now, this is an improper fraction. That's okay. We're okay with improper fractions in this section. In the next section, we'll want this as a mixed number, but for now, this is okay. And 49 and 48 don't have any common any numbers that we can divide both by. Right, 49 is only divisible by 7, 7 and 7, and 48 is not divisible by 7. So that's it. That one's done. So if you're using the prime factorization on this one, yeah, you do end up with this this looking multiplication right here. But and you noticed that there is no matches in the numerators and denominators. I mean, there's matches in just the numerators and matches in just the denominators, but none in both that could cross out into phantom 1s. So what that would mean if you used prime factorization on this one is you're just going to, essentially you're going to do what we did up here and multiply these values straight across. And yeah, I mean, you'll end up with the same thing. 7 times 7 is 49. 2 times 2 times 2 times 2 times 3 is also 48. And this again, is just another way to prove that it could not be further simplified what we got, because with the prime factorization, there are no matches in numerators and denominators together. They've got to be one in both. Now let's go and divide this one. Now be careful because sometimes on the quizzes or tests, or I mean not on the homework where this specific section is with division, but where tests and quizzes sometimes mix the methods or the operations, I should say. Students will look at this and they'll say, hey, look, the 5 and 10, I know I can simplify those, at least if you're using cross simplification, and then 3 and 12 could be further simplified. But remember, that's only if the operation is multiplication. So the first thing that we need to do on this one is to change the operation of multiplication. So I got my 5/12 right there in my dividend, and I am changing the operation of multiplication. So instead of showing this as 3/10, I'm going to show it as 10/3. So at this point, we look and we see, well, it's I don't see any common, well, no, I do. I'm sorry, the 10 and the 12 right there. So let's see, you know what, since that last one didn't lend itself towards the simplification at the end, I'll do it on this one, okay? So that means I'll say, let's just do a straight multiplication on this one. You could use prime factorization. You could use cross simplification. You'll end up with the same answer. So if you're using those methods, just make sure that you check at the end here with what we get. So 5 times 10 in the numerator, that's going to give us a new numerator of 50. 12 times 3 in the denominator, which will give us a new denominator of 36. Okay. Now this is not simplified. I know that because in my ones place values, I have even values, 0 and 6. So I know both of these, the numerator and denominator, can be simplified by dividing by 2 here. So that will give us a new value. So, and just in case you need the long division, which is okay to do, 2 will go into 50, 2 goes into 5, 2 times 2 times 2 is 4. Subtract that to get the 1, drop the 0, make that 10. 2 goes into 10 5 times. 5 times 2 is 10, 0 remaining, so I get a 25 there in my numerator. And then in the denominator, we have 36 divided by 2. 2 will go into 3 once. 1 times 2 is 2. Make that 1 drop the 6 to make that 16. 2 goes into 16 8 times. 8 times 2 is 16. 0 remaining. And so that quotient there is our new denominator. I'll fix that 8. There we go. Okay. Now, of course, you could say, well, I'll split up 50 and 36 into its prime factors. So be it. You'll get the same answer. And looking at this 25 and 18, 25 I know is divisible by 5. 18 is not. 18 is divisible by 6, 3, and 9, but 25 is not. So that means that we've reached the end of this problem. Whichever method you use, again, it's really up to you. But let's see. I'll do cross simplification on this one because we did just multiplication right at the beginning there. But before we do any cross simplification, of course, we need to change our operation from division to multiplication. So once again, I know you'll get tired of me repeating this, but our dividend of 3/14 is just going to stay the same with division of fractions and even the changing the operation. But the 15/4, our divisor, needs to be reciprocated into 4/15. All right. Now I am looking for any cross simplification that can be performed on numerators and denominators, but it has to happen simultaneously. And so I noticed, at least for me, you may have noticed the 4 and 14, which we'll get to, but the first thing I noticed was the 3 and 15. Both of those are divisible by, 3. So I'm going to divide them by 3. All right, so that's going to change at least those two values in this problem. 3 divided by 3 is 1. That's the top left value. And then 15 divided by 3 in the bottom right becomes 5. Now that just simplifies those two, but I have the 4 and 14. Now let's say you didn't notice the 4 and 14, by the way. Okay, I am going to simplify them, but let's say that you didn't. Well, you can keep them the same, which means that, if you wanted to, you could write them in here and here. And then, again, if you still didn't notice, you could continue to multiply at that point. I did notice, so I am going to cross simplify those at this time. But again, if you didn't, it would still be okay. So I know they're divisible by 2. So I'll divide the 4 by 2 and the 14 by 2, which will give us new values in those places of the fractions of this problem. So 14 divided by 2, that's 7. Whoops, that didn't come out very good. That's a little better. 4 divided by 2 is 2. Okay, so I simplified each of the values in that fraction. And again, it's cross simplification because, well, it's done crossways like this. You could simplify in some cases. We did say this. You could simplify straight up and down. That's fine too. But I notice now that I can't further simplify any of these. Okay, so if we missed something and they could be further simplified, then we would, but we can't in this case, which means that we just need to do multiplication straight across through numerators and denominators, which will give us a new numerator and a new denominator. In the numerator, I got 1 times 2, which is 2. And in the denominator, I have 7 times 5, which is 35. So this ends up being our final answer, 2/35. We've seen this slide before, by the way, and I'm not saying that you have to love it, but you'll see it, okay? So just remember, and I know we've gone over this already today, but I'm going to restate it, okay? If you see just the whole value, and we're dealing with fractions specifically, I would say that it'd be nice to show it as a fraction like this. So if you see a whole value, just change it into a fraction. And so I used 5 before, so let's use, I don't know, 7. I got to work on my 7s on this iPad a little bit better. Remember, if you wanted to show it as 7 over 1, you could. And this will allow us then to start operating with these fractions, no matter if that whole value, whether it's 7 or some other number, it could be the dividend, it could be the divisor. If it's the divisor, this is important because if I wanted to reciprocate this, right, then it's important to know that it could be reciprocated, just like we saw in those examples for reciprocation. This would be 1 over 7 then. See that? If you reciprocate it. So here's our first example with a whole number, the 9 right there. Now, we are going to change this operation to multiplication with this fraction business. But even before I do, I do want to show the 9 as 9 over 1. Okay, now whether you do that now or later or even never really doesn't matter because it's the dividend, right? When we have a dividend, it does not need to reciprocate. Okay, so I'm going to keep it as 9 over 1. I am going to change the operation. Instead of division, we'll have multiplication. And then I will reciprocate the 27 over 2. Since it's reciprocated, it will be 2 over 27. And again, the reciprocation allows us to change that into multiplication. So at this point, so I did cross simplification on that last one. I'll use prime factors on this one, okay? So I see the 9. I know it can be split up into more prime factors of 3 and 3. All right, so we'll write those in as many as we can. All right, so the 2, it cannot be split up into prime factors. It's already prime, and the 1 is neither prime nor composite, so it's just going to stay 1. But the 9 I can split up into 3 times 3. Now this will be important because 27 can also be split up into, I'll say 3 and 9. 3 is prime, and then 9 we've already seen splits up into 3 and 3. Now that's 3 3's multiplied, 1, 2, 3. So I changed the 27 into 3 times 3 times 3. I do need a little bit of extra space there, don't I? So again, with using prime factors like this, now what we're going to do is look for any matches in numerators and denominators. And we're going to cross those out, like these 3's that match, the green and the orange. And again, we're crossing those out. They become phantom 1's, not 0's. They don't cancel away like they've just gone away. But then I've got another 3 right there that I can cancel out with another 3 in the denominator. So that's as many matches that I find in numerators and denominators. And so what am I left with? I got the 2 in the numerator, so it'll stay in the numerator. In the denominator, I have 1 times 3, which is just 3. So this looks like it's our final answer, 2/3. Now again, the crucial thing here is that you notice that division is, and hopefully this is getting down pretty well now that we've gone over, I guess this is our 5th problem, but we don't actually divide those fractions. We've done a lot of multiplication, hopefully, at this point, especially if you've done the homework. So as long as you can multiply these fractions, division of fractions should not be a problem because, again, just reciprocate your divisor and then multiply, you're good. There we go. All right, so on this one, we got 5/9 divided by 20. Now, again, this time, the whole value, the non-fraction value, is the divisor. So I'm going to definitely want to show that as 20 over 1. Again, we are going to change the operation to multiplication, but our 5/9 dividend will stay 5/9, even though we are changing the operation to multiplication. But that 20 over 1 is now going to become, as a fraction, see if I can clean that up, as a fraction, there we go, into 1 over 20. So let's see, I did prime factorization on that last problem, so we'll just do straight across multiplication on this one, okay? Now, some of you noticed that the 5 and 20 could be simplified, and that's fine. Or you'd start splitting the 9 and 20 up into their prime factors, which would be fine. You should get the same answer either way, but I'm going to do multiplication on this one, which means I'll simplify in the end if we can. 5 times 1 there in the numerator is 5. That's pretty good. And then in the denominator, 9 times 20. I'll stack these to the multiplication. I know not everyone needs it, but I'm going to show it anyways. 9 times 0 is 0. 9 times 2 is 18. We get 180. That wasn't even that bad multiplication. But then I see I've got a 5 in the numerator and 180 in the denominator. And 5 and 0 in the ones place value indicates that both of these could be divided by 5. They're both divisible by 5. Now this will give us a new fraction. That's okay. I know 5 divided by 5 is 1, so I'll just put that in right there in the numerator. But I will need to do 180 divided by 5 for my denominator right here, okay? So 5 won't go into 1, but it will go into 18 3 times. 3 times 5 is 15, so I'll subtract that out. 18 minus 15 is 3. Now I'll drop the 0 to make that 30. 5 goes into 30 6 times. 6 times 5 is 30. So yeah, this subtracts out. We have 0 remaining, which is what we want. But our quotient there, 36, is our new denominator. So again, we used just simplifying at the end. And yeah, we got a 1 in the numerator, which means that it couldn't possibly be further simplified. So 1 over 36 is our final answer. You should get the same answer no matter what method you use.